Hello and welcome to Raspberry Pi tutorial, in which I will teach you how to process analog data. But before we continue, there are some prerequisites to completing this tutorial. They are on the screen right now. If any of these steps haven't been completed yet, feel free to go and follow our tutorials to do so, and come back here when you have everything set up. So, what is analog data? Unlike digital data, which only has two distinct states, analog data forms a continuous spectrum of values. A good example of this is an LED, which instead of being just on or off, can be of varying brightness. And another example of an analog device is a light sensor, which can sense different values of light. And this is what we will use to produce analog data in our program. First of all, let's connect the Grove light sensor to the port on the Grove Pi board labeled A0. Here, A stands for analog. Then, moving on to the console, let's navigate to our home directory, and here we will create a new folder for the project. We do this by using the command make dir light, and open up that folder by using cd light. Here we will create and open a new Java file for editing by using the command nano light.java. We start populating our program by declaring the relevant imports at the top. This will allow us to manipulate the Grove Pi and its sensors. Feel free to stop the video at any point to copy the code to your program. Now, below the imports, we define our class called light and create a main method inside it. Here, we create a new instance of the Grove Pi board, which will allow us to communicate with it. We can now read in the analog data produced by our light sensor. We do that by using the command Grove Pi analog read and specifying the pin the light sensor is connected to. To poll the sensor continuously, we define an infinite loop. As after conversion, the voltage from analog sensors in Grove Pi is represented by a 10-bit value, which has 1024 states. To make this information easier to use in our program, after reading in the values, we divide the result by 1024, which will show the level of light as a fraction of 1. This is it for our code, so we can save it by pressing Ctrl X, pressing Y to agree to the prompt, and Enter to confirm the file name. Before we can execute our program, we first compile the code by using the javac light.java command, and then to run it, we type in java light. If everything worked, now on screen you should see a continuous stream of numbers representing the light values, and covering the light sensor should make them closer to 0. While exposing it to light will bring the values closer to 1. This brings us to the end of our tutorial, and at this point you should be able to process analog data and incorporate this functionality in your programs. So, thank you for watching and good luck with your Raspberry Pi projects!